groups you want to compare?
I have 3 groups.
3 groups. So then it is to do the ANOVA. ANOVA, do you know?
Analysis of variance.
Yes, it's analysis of variance.
Right.
So first, the Shapiro test is this is Shapiro. This one. And right, this one. Shapiro test, and augment is the x equals data set. Data set means if you have the wild type and the mutant 1, mutant 2, then 3 times each experiment. You have the data set of the data set, and this is a group. So you have to なんていうか assign the some variable. A variable is anything is okay like that. X for data 1, and in our software, the code of code for the assign is there, like the arrow hyphen and the
less than arrow.
No, mean that, and the data set is always always should be the vector, and in our software, vector and vector formula is the C. C and data 1, comma, data 2, 3. Then comes data 1. Data 1 is also okay for the white type. White type, it is better to do the not cap, but small. And so then please assign the white type data and the mutant 1 data, mutant 2 data. This is signed with your our software.
Mutant 1 data is SS2 delta.
Yes. And the variable is isn't the same as the white type. If you are spread see this data set in the data 1, data 1 is data 1. The name of the data 1 is not be able to use some other mutant 1 or mutant 2.
So the name should be changed.
Yes.
So it is data 2.
Data 2 or data 3.
Data 2, data 3.
Yes.
Data 2 for mutant 2, 1, SS2 delta. Data 3 for mutant 2, SS2 delta. Hi.
And then, please be your and do you have the data set for the?
Yes, I have.
Do you want to analyze it?
Yes, I have got my data set.
All right.
I have got this 3 sets of data.
Okay.
1 to 3, 1 to 3. For BY, SS2, SS22.
No, okay, then
and this is my R software. Is it okay?
Okay.
Hi,
And
hi,
then
hi.
the assign to the data one, or for example, data one.
Data
Assign
one.
as the vector.
Data one. Okay. Data one. Data two. Okay. So data one, data two, data three.
Okay. So yes. And then you assign the data one as the data one in the R software. Okay. Please open the R software and please type the data one first. Yes. Yes. Okay.
It's okay.
Data one. Please type data one.
Space. Data space one.
No, not space.
Okay.
Yes. And then space.
Space.
Then the
arrow.
arrow. Yes. Arrow.
This arrow. And then
yes, and the hyphen. Yes. Then space.
Space.
C. And
Bracket.
Yes, a bracket. Yeah. Then the data point of data.
Points of data.
Point of data 1 and 2, 3. 1, comma 2, comma 3.
Hi. Comma. Sorry. Azuma-san wants to know. Data. Then.
Yeah, that's so. Yes. Oh, sorry.
The copy paste is not allowed, maybe.
Yes.
Oh.
Sorry.
Then I have to.
Right. Yeah, right. Yes, right.
So I have made a mistake. So how can I delete this plus and?
Then once click sorry and type the enter. Yes. Oh, no, どうしようかな。Then no, please once enter. Press enter. Yes.
Enter.
なんで Okay. これできない。
Plus.
Quite formula is to break the.
Now
running.
it is called.
Yes.
Hi. Hi. Data space. This one. Space C. First bracket. Write down the data. 8.3. 8.3. 3 number followed by dot is okay. 3 number.
Yes, 3
followed
number.
by is okay.
It's okay. Or okay.
3 comma 0.831 0.581 set is done. Bracket close.
Yes, it's
1,
cross.
2, 3 brackets close.
Then and press enter. enter key.
enter.
Okay, then
Data.
data. Yeah, but data is okay. And if you confirm the data, please call the data and press enter. Then call the vector. You press you wrote the 0.833, 0.8.
This is confirmation.
Yes, and now this set of the this set of the data assigned to the data. Name of the data. Okay. So then please assign the mutant one and mutant two.
Hi. 0.625 0.85 625 805 234 hit enter, write data. Now press enter. Data 2. I have to write data 2 maybe.
And data 2. If request data 2 and press enter key. Data 2. Yes.
Hi. Data 3. Space. Zero 19388455524. Now the preset of data is taken by the software.
Okay. Then execute this code, softawre.test, and the augment is this notepad variable.
SAPIRO.test bracket data1.
Yes, data1. Data1 is not the consistent, but this is a
variable.
Yes, a variable. Yes, a variable.
Data1 is
a variable. Yeah. You decided. Data1, data2, data3. Wait.
Among these data, one is variable and other is dependent.
Yes, dependent.
Dependent means is like this. So y is equal to x plus c. Y is
dependent variable.
Dependent on x. X is a variable.
X is variable. Independent.
Independent.
Yes.
But y is dependent on x. So among these three data, I have to choose someone that will be
this data point. Now this is the not dependent. Now this is an independent variable, but if you want to execute the ANOVA, you have the send other data. Data define the labeling of the dataset. So then this data came the dependent variable.
To analyze
yes.
the ANOVA, I
So,
have
yes,
to set someone variable.
yes. So then you if you want to the Shapiro will tells now this is the not dependent variable but the independent variable.
Independent variable.
Yes.
Shapiro test now.
No independent.
Now it is independent variable.
Just this set of the data.
So I want data only this set to be independent.
Yes, independent. Data.
Independent variable.
Yes.
So
perfect. The not to go and this is a variable that contain a consistency.
Variable but contains
Content. This is the but this data is the data are consistent.
consistent.
So,
Yes, consistent means it has a definite level of values.
Yes,
consistent means consistent.
Yes.
Okay. Consistent. Okay. Now then I have to type that Shapiro test in here.
Yeah.
Next step is
the next step. Okay. Then first do the Shapiro test in the so the data. The variable is data.
how did you perform Shapiro?
Write the Shapiro.
This.
Oh yes. This is for the
This is a
Shapiro test. Shapiro.
Test test. Then bracket data. Bracket data.
Sorry. I said that consistent, but not constant.
Oh, constant.
Sorry. I really mind it. Sorry.
Constant.
Sorry.
Constant means it will not change.
No change. Sorry.
Okay. So Shapiro test. Shapiro.test in bracket.
In bracket data.
Only data.
Only data.
Data.
This is called the argument.
Argument.
In the bracket is the argument. Argument, yes. Argument is the data. Now data.
Data bracket closed.
Bracket close and execute. Press enter. Then the p-value. 0.01. So this the null hypothesis is sorry シャピロミルクのヌルハイポテシスが
0.005
under the 0.05 then you
and like this greater than 0.005
0.05 means 0.5%. So 0.05 isなんだっけ1ってなんていうんだっけ
this will be a significant p value.
Yes, it's significant p value. The cutoff value.
0.05 cutoff value. Cutoff value.
This is. And Shapiro.
W means what? W means it's what is W?
W is なんていうのかな統計量って。The statistical quantum, not quantum, but statistical なんていうんだ統計量。Sorry, I don't know in English.
Maybe statistical term.
Yes, term, but okay. And then, sorry.
So this p value indicates that
now Shapiro tells the null hypothesis is the the same as the normal distribution. So normal distribution, and now your data point is somehow what the this is a normal distribution, or some other distribution.
Other distribution.
Okay. This null hypothesis is uh, the same as the
Normal distribution.
normal distribution. So means and no significant
Change
in the from the normal distribution.
normal distribution.
So then, but this can be dismiss this null hypothesis. So the admit the alternative hypothesis. So then it may not the normal distribution. So and this is not good.
Not significant.
Not significant mean not significant, but
But it is significant distance from the normal distribution.
Yes, and this is a significantly
distance from the normal
yes.
distribution.
So it means that not the normal distribution.
This is not normal distribution.
So it is not good, but the Shapiro-Wilk test is just their confirmation. So now, if you want to do, you can do this Shapiro-Wilk test, but it is not need to always you do the Shapiro-Wilk test. I think.
So among these three sets of data, the normal distribution has been changed. This result indicates the normal distribution is significantly changed.
Yes.
It should have been 0.05. So, but actually it becomes 0.01.
Yes,
so there is a large difference between the normal distribution to the actual result. So there is significant difference.
From the normal distribution.
Yes. Hi, wakarishimashita.
So then, this is the explanation for the Shapiro-Wilk test.
Hi.
Then now you do the ANOVA. Why do you use the multiple comparison? Sorry.
Multiple comparison.
Do you know why you use the multiple comparison instead of the t-test? Or?
No.
Okay. Now, if you repeat the t-test, okay, I create the slide. Sorry. But in Japanese, sorry.
No problem. Let's do this.
This one. Sorry, multiple comparison. Now, if you repeat the t-test, so means what do you want to know is whether there is some significant difference between the A, B, or A to C, or B, C. And this vertical. No, sorry, vertical. And
this column.
Yes, this column. And
this data set, and this.
Yes.
Whether there is significant difference between them or not.
Yes.
Hi.
Okay. Then if we determine to decide the alpha means the significance level as 0.05. This the probability of there is no significant in the this formula 1 minus 1 minus 0.05 to the power of 3. When the three groups, the to the power of 3 means the number of the repeat. 1, 2, 3. If it can 4 groups, you can add 4C2 means 2 1 by then came the 6 to the power of 6.
This, if there are 4 groups, then this will be 4?
Not 4, but 6 at the 4 group. In the 4 groups came the 4C2.
4C2. Permutation combination.
Yes.
Hi.
So then the 6.
4C2. 4 groups. Hi.
4C2.
Then it becomes 6.
Becomes 6, yes. Then if in the 3, in the case of 3, this came the 1 minus 0.995 to the power of the 3 came the 0.143. So then the significance level is increased. So this is not good. So it can be adjusted. It should be adjusted. So then we use the multiple comparison other than t-test.
T-test.
So okay.
Okay.
Then now use the ANOVA.
Analysis of variance.
Yes, analysis of variance. Then your factor is 2 or 1 or 2 groups, 3 groups. Means maybe factor is 1. The difference of the strain. Only the difference of the strain.
Only the difference of the ratio of the free-ZP. Ratio for 3 groups.
The factor is just to depend on the.
What type of thing is I am comparing? Maybe considered as factor. I am considering only one factor. That is the ratio of free-ZP by free-ZP plus knockout. So there is only one factor I am considering.
Okay, then there are one way ANOVA. Okay, then. Now it's one way ANOVA, and then we use the one way ANOVA in the R software. The formula, ANOVA formula is AOV, AOV, and bracket, this came the dependent variable. Yes. Dependent variable tilt and okay. Independent variable. Or some other case, the second argument is the data set. But in this case, the dependent variable is the same as the data point. Okay. And the independent is the strain.
Independent is the strain.
Strain means wild type and the mutant. Yes. So then you have to prepare the dependent variable and the independent variable. Then the dependent variable came the どうしようかな. Okay, then and also this both also should be, must be as a vector. Vector.
Vector.
Yes, vector. This is
Factor. F-A-C-T-O-R.
Vector.
Vector. V-E-C-T-O-R.
Yes, a vector. Vector. It's vector. And say again. Vector can the C bracket. The augment is your arbitrary number of the augment. You can contain this vector. So means 1, 2, 3, or this is not limited for the number, but the numeric. But you can contain the dog, cat, and so on.
Number
or
things.
Yes, things or the strings. If you wanted the contain strings, it needs to the double quoted.
Double quoted.
Double quoted. Dog, cat, these are.
Right.
Okay. Then okay. Then now now define the dependent variable as どうしようかな。まあいや。Now I use data. And this is the algebraic or the assignment. And the vector formula in the number. This is a y type. And this is the negative one. And so on with the 2, 3, or 4. Okay, now please make the vector for the and assign the variable. Then okay, then どうしようかな。Okay. Please.
Okay. Vector is C. Vector will be WT, SS2, SS22.
Yes. Okay. WT, no, 3 points of the data. Okay. Y type, meter to meter. Okay. And this became the dependent variable. Sorry, dependent.
Dependent, independent. What is okay?
Depend on the traits. And compute depend or independent. Sorry.
Statistics is very critical thing. Very difficult. You know, in our country, lots of students drop out from statistics. Drop out means they cannot finish their honors due to in statistics and in physics.
Yeah. It's too difficult.
So, this 1 to 3 is for wild type.
Oh, yes, wild type. And yes.
Now I have to put double comma?
No, double comma. This one.
A double comma for dog, cat, like this.
Yes, for the string.
Yeah. Not for data.
Not for data. Not in the our software. The it is without the double quote. It all strings can recognize as the numeric.
Oh, numeric.
So yes. So
Dogcat also they do not count as dog. They count as numeric. 1, 2, 3. Hi.
Became the numeric. So then.
So this 3 is voltage, comma. Comma. 1, 2, 3 set. 845, 0.524. Bracket close. So 3 sets of data.
Yeah.
1, 2, 3.
0. You forgot the 0.
Oh, 0. Okay.
Okay. 0. And cross. Okay. No, sorry. you wouldn't
Created the vector?
Not the decide a variable.
So first I have to put like this.
Yes, but yes.
Then
yes.
finally like this.
No.
No.
Just this is a to restart the statistical analysis. You can forget the upper one. And then they came the cursor. And like anything is okay, but now you write the data. Data. Yes.
Then space. Like this.
Then press enter key. Then came the assign this vector in the data.
Now it has become a vector.
Yes. Now this is vector.
Vector. Oh.
This one is the row. No. Row vector.
Row vector.
Row vector.
This row vector.
Yes, it's a row vector.
I have to put it into column.
Not column. Column vector can be created in the Excel or some.
Oh, hi. But it's no.
Yeah, okay.
Now, what should I do?
Then, please confirm the data set of in the data. As a call the data.
Data.
This is a confirmation, and then
press enter.
Then this is a vector.
Hi.
Okay.
Hi.
Then you define the dependent variable. So now independent variable. Independent variable is this one. This one is independent.
Hi.
So then the independent. So anything is okay. For example, the string. Okay. The vector as a vector. And the y type. Comma y type.
2 or 1.
No.
Only one.
Same. And then mute 1.
Hi.
This is the label for the data set.
String C strain strain space.
This is not limited for the strain, but the treatment or some
other thing. Strain is not a fixed word.
Yes.
Many words can be written. Hi, very much. WWD. Then yes. Okay. Oh, finished.
Okay.
WWT
Yes.
2022.
Okay. Then press enter key. Okay. Then string becomes the independent variable. Okay. Now, if you want to the two-way ANOVA, the independent variable can two. And somehow the treatment. For example, the control, and 1 hour, 1 hour, 1 hour, and so on. Now, if you want to execute the two error, the code can the error dependent variable, means the dependent is the dependent, and this is a independent. Independent 1, 2. Dependent variable tilde independent 1 asterisk independent 2. This can execute the two-way ANOVA.
One asterisk. But
yes.
The independent variable. Hi.
Okay.
Treatment and strain are independent variable.
Yes, independent variable is.
And
sometimes the two factor came the independent.
Hi.
Okay. In this case, you use this code. Okay. So the AOV data to string. Data to the string.
For one way. This is for two way.
Yes.
So I am going to use one way.
Now the argument is only one.
Only one, yes.
Dependent to the
AOV
space. Not this.
No space. First bracket. Dependent variable is my data.
Data, yes.
Data.
Variable named data.
Data, only data. Then this sign.
This sign tilde. The tilde. Yes. Okay, data and the string. Independent.
But we didn't put the string in the system. String is in the red color. But the data is in the blue color. Data is in blue color. That means data has taken by the software. But string is not taken because it is red color. Is it okay? My question is, after writing the data, we.
And this is a confirmation.
Confirmation.
No.
But string is not confirmed yet.
Yes. Okay. If you want to confirm, please call the string. Sorry. This is convention. It is.
Now it is
Then this is a vector.
Okay.
Then
UV.
the LV. The first dependent.
Up to independent.
Independent is
strain.
Yes, strain.
STRN strain.
And the cross.
Bracket cross.
Then execute. Then came the there's no significant difference. どこだっけ
Call LB terms strain residuals sum of square is 1 degree of freedom 26 and residual standard error 0.2328108.
あれ P バリューが出てない
Estimated effects may be unbalanced. What is the p value?
あれ There is no P value.
Right.
Sum of squares あれ Sum of squares and degree of the freedom.
Maybe
Degree of freedom. And
UV for one dependent to independent, comma data, but we didn't put any comma.
Sorry. I confirm.
Okay,
Sorry.
no problem. This statistics is, you know, many people while finding the formulas for mathematics become mad.
Okay.
Not the point.
Okay. Maybe this value is hidden. So then どうしようかな。Okay, summary. The summary 書けない。
SUAMMARY. Yes.
MMARY.
Correct.
Summary. And AOV. Blah blah. Summary. Yeah. Maybe summary formula.
Summary.
Summary formula came.
AOV bracket.
Yes, bracket, AOV, bracket, and the cross bracket.
Oh, close bracket. Let's start. SUMMA summary.
This came the showing
AOV.
Maybe. It's difficult for me.
Error in terms.
Program. Oh, sorry, but AOV that. Sorry, AOV. So, this one, AOV. Dependent to the independent.
So, summary bracket AOV bracket data to the strain. But in your formula, you put dependent up to independent, comma data. But I didn't put any comma.
Yes. The second format is if you want to use some other data, some other CSV file or some other data, it can be
included.
Selected.
Yes. はい。わかりました。
Second format is not required now.
Now. Square mean square formula.
Oh, it's a p-value. This one is the p-value.
This is p-value. 0.522.
So then not the significance. So then there is no significance in your data set. But if you want to so as may you know that the ANOVA came whether there is a significant
with data wizard, W-I-Z-A-R-D, wizard.
Wizard. If you're yes, wizard. Another case. Whether there is some significant difference in your three groups between the three groups among the three. But this not show the not the where
the difference.
Where the difference?
Hi.
Then not it have to execute the multiple comparison. If you have the significance, you got the significance in the ANOVA. You have to do the multiple comparison.
If I got it is significant, then I have to multiple comparison.
Multiple comparison is どうしようかな. I recommend the Tukey, the Tukey HSD, Tukey HSD means なんだっけな Tukey so I forgot what means HSD, but Tukey.
So my data is not significant.
No, not significant, but
so it means that there is no significant relationship between this one, and this one.
Yes, so there is no significant difference.
But no significant difference?
Yes, no significant difference.
They're all
among the three groups.
This value, this one?
Yeah, 0.5. 0.5 means 50%.
Square mean square.
Now
F value is 0.7 and PR greater than
this
F.
is a P part.
P value 0.5 means 50%.
50%. And now null hypothesis is there is no there is no difference among the three data, three sets of the data. So and this shows that the probability of the null hypothesis came the 50%.
50%. So we assume that there is no difference between the data,
yes.
And we found that there is a 50% chance of difference.
The 50%. No, this isn't just the probability.
Probability of 50% probability of variation among the data.
Yes. Variation. So in the
it is about 50% probability is a good probability.
Good probability for admit the null hypothesis.
Not admit the because null hypothesis is already 50% lost. Your null hypothesis was there is no difference between the three.
Yes, there is no difference.
It was one null hypothesis.
Sorry. There is no significant difference
among these three set of data.
Yes.
It was our null hypothesis.
Null hypothesis is that there is no significant difference.
Yes. And we found that there is 50% probability of difference.
Is not dismiss the null hypothesis.
Yes, correct. Now the null hypothesis is dismissed.
Now not dismissed. This is not for acceptable for the dismiss null hypothesis. 50% is the
50% dismissed.
No. 5%.
5%.
0.05.
0.05. But we got
is acceptable for the dismiss the null hypothesis. So then came the 0.5. 50% is not
0.05 indicates it is dismissed.
Dismiss the null hypothesis.
Indicates
so there is dismiss the no significance. There is no significance.
Dismissed. This is a very critical point. No significant difference is our null hypothesis, and if the p-value is 0.05, that indicates the null hypothesis is dismissed.
So then the alternative, admitted, alternative one
now
means
admit the alternative null hypothesis.
Null hypothesis. So then came the there is the significant difference somewhere.
So 0.05 dismisses the null hypothesis, but we have got 0.5.
0.5 is 50%.
50%.
So then it is it may suitable for the null hypothesis.
It supports our null hypothesis.
Yes, it supports.
No significant difference.
50%
supports our null hypothesis.
If it is less than the 5%, it can it may
5%. Dismiss the
difference. It is not suitable for the null hypothesis.
Null hypothesis. That means significantly different.
Yes, there is. But another came the not where, but with what if there is no there is the significant difference. So then it is have to do the multiple comparisons.
Now our hypothesis is okay.
Now this one can't dismiss the null hypothesis.
So we do not need multiple comparisons.
Yes.
Because our hypothesis is still supported by this result. We assume that there is no significant difference. And it came that
support the null hypothesis.
Null hypothesis. So we do not need to undergo the multiple comparison. Statistics is very difficult.
I think so too. And but this is for a tutorial. So then, once do the multiple comparison in this data set, okay, and then several kind of there is a several kind of multiple comparison, but I recommend the 2-key HSD. 2-key
HSD multiple comparison.
2-key one. TUKEY.
Turkey.
Turkey.
TURK.
Yeah, TURK.
Turkestan.
You know.
I know the name. Turkey. In SPSS. In SPSS software, I applied this for the comparison of two sets of data, whether they are significantly different or not.
Okay. Turkey. Yes. Turkey.
HSD.
HSD. Yes.
Oh.
I know.
Multiple comparison. Okay.
And now the 2-key HSD is the comparison depends on the confidence level. Then the code execute the 2-key HSD is change the ペンがあった。9キーが9キー this is a cap. T-U-K-E-Y. T-U-K-E-Y. はい。2E HSD. HSD
is capital letter.
Capital.
はい。
And bracket. Not AOB.
AOB.
Also AOB. The
bracket.
Yeah. That. Tiered. In that.
はい。
And confidence level. Sorry. This one. CONF. Conf. Dot level.
Confidence level.
Conf dot level. Equal. Confidence level is. Any point of the confidence level is okay, but I recommend 0.95.
0.95.
This is the 95% confident.
High.
And close the bracket.
Okay.
And then execute it. This is
T-U-K-E-Y to SSD UV dependent and independent data straight data to straight bracket to close confidence level CONF LEVE 11 confidence level is equal to 0.94 bracket to close execute.
Okay. Then this is a lower confidence, not the lower edge of the confidence, and the upper. And the p value, adjusted fit value. This is one came down 0.5 or 0.6, 0.9. There is no significance.
Between the SS22 and 2, the p value is this one. For wild type and SS2, the p value is this one, and wild type and SS22, the p value is this one. So our null hypothesis was it should be 95%, and this is 97%, more than our hypothesis. P value.
Sorry.
Confidence level was 95%.
So then came the significance level came the 0.05.
This is 0.03.
0.0. No, this is just the p value.
P value, 97% probability.
Yeah. So then I mean the
null hypothesis. So it is 97% correlates with our null hypothesis. 64% and 53%.
Yes.
So there is no significance.
And then it is consistent with this result.
This result.
Yes. Okay. Okay. Then there is other simulation of the multiple comparison, but I think it is recommendable. Bone felony correction t-test or form correction t-test or
recommendable.
Recommend. Yes.
High.
Okay then. Okay then maybe you can do the statistical
analysis of my data.
Okay. But there is no significance.
So there is no significance means there is no difference.
No difference.
No significant difference.
Yes, no significant difference. Yes.
Although it seems that this is higher, this is lower, this is higher, but statistics says that there is no significant difference.
No significant difference, but it can't be said that as a no difference. Can't be as a no difference, but no significant difference.
No difference and no significant difference are
different.
Two different things. はい、わかりました。
Okay.
Okay, thank you. And I have another query about calculation of the free GFP with the full length GFP. So I have to, do I need to take into account of the PGK value also?
No, PGK value, PGK is the loading control. The PGK is the kind of the なんていうのkind of the なんていうのsorry level of the entire protein.
PGK indicates that whether this experiment has been done with the accurate volume of the volume applied or not.
Yes.
So during calculation of GFP and knock-on GFP ratio, no PGK value is included.
Yes, because yes, if you want to compare the only GFP one, the only one one, it is need to normalize by the PGK one as a loading control, because the one when in this case the normalize to the entire GFP volume. GFP volume means maybe GFP might be processed by the full length. All of the GFP, all of the free GFP might be processed from the full length. So then the sum of the full length and the free GFP means the possibility or the なんていうのかなchance or
probability, chance, possibility,
or not possibility, but the possibility of the including the included the protein. The cell included
protein in the GFP.
Yes, as a full length.
As a Florence.
Sorry. Okay. The expression level.
Protein expression.
Expression level. The sum of the full length and the free GFP is the expression level.
There is a chance
of the full length. Full length means like the 4/8 or the now you.
This is my free GFP. Okay.
This is what GFP? What?
For wild type.
Sorry, but what protein you fuse the GFP? GFP, like the GFP 4/8 and no point GFP.
No point GFP.
No point GFP. Okay. Then this two band, the total of the two band came the expression level of the no point. So then the normalized to this total of those band means normalized to the expressed no point.
Only no point.
Yes, no point.
Background is deleted.
Yeah, background is. And but your if you analyze the only free GFP, the no point expression level is not the same in those three independent.
Right.
So it is have to normalize to the protein you loaded. Then the monitors as the PGK one.
Hi.
You got it. No.
Sorry. No problem. But I want to show you the formula, whether I have the formula correct. My formula is this one. Formula is ID minus ID. ID means
ID.
you forgot ID.
ID minus. Sorry. ID.
Area, then ID.
ID means integrate of that density. Yes.
Hi. So the formula was integrated density minus integrated density divided by area.
By area, yes. This formula. This you want to know this?
My formula is okay or not?
Okay, sorry.
Integrated density minus integrated density
no blank
divided by area of a blank, then bracket close, multiplied by area.
Yeah. Yes.
Okay. And the ratio is free JP divided by full free JP plus full length.
Yes.
So
okay.
So there is no PGK.
Yes, there is no PGK. Okay. So because this is normalized to the expression of the not one. So this is okay for the without the normalized to the loading control. Yes, because the expression of the expression level of the not one came as the same as loading control. Work as the same.
Not one.
Yeah.
Not degraded. Is as black as the loading control. But when the knob one is degraded, it becomes straight. But this knob one is still in the black. This PZK is black.
Yes.
Indicates
PZK one is not degraded.
Not, but this level indicates that it was loaded in correctly. Loading control means it indicates that it is loaded correctly.
Yes.
There is no variation in the amount.
Yes.
Currently loaded. Yes. So, according to your argument, I came to understand that when we are applying the formula, we are trying to assess the degradation of NOP1 in terms of GFP.
Yes,
sorry. NOP1?
Yeah.
GFP. When the NOP1 is degraded,
yes,
GFP becomes free.
Yes, GFP free.
Is the NOP1 degraded more? There will be more GFP.
Yes.
NOP1 degraded less, there will be less free GFP.
Yes.
So, NOP1 degradation is indicated by the amount of free GFP. So there is no need to calculate the PGK.
Yes, yes, but yes なんだけど but this is not the because of this one, but the all of the data must be normalized to some other factor.
Normalized means like this. For example, normalization in case of UV spectrophotometry. This is my cuvette. It contains suppose BY plus DW. If I want to know its actual value, actual UV value, then at first I have to auto zero the DW.
Yeah.
So the auto zero of DW value is the normalization.
Not normalization. This is this is not the normalization, but これはremove the background. Removing the background.
Yes.
But the normalization is the なんていうのかな came to the ratio of the for the some other means low value is the very なんていうかな very
low
different low value.
If
Yeah.
there is very fluctuation of high and low, this may be 100.
Low means
Row
ROW.
ROW
RAW.
raw value.
Raw value. Sorry.
Raw value. Okay,
Raw
no
value.
problem.
Sorry. Raw value.
So
Sorry.
if the raw value is very fluctuated,
yes. So
fluctuated means this may be the raw value may be this level, and then maybe this level, maybe this level,
yes.
maybe this level. So there is a fluctuation.
Yes.
But we have to bring this in the uniform line. So then we have to march this one to upperward, like this level, and we have to put this one into lower line into this level.
Yes.
So it becomes like this. So
No,
this is called normalization.
This is a normalization.
Hi.
And if you want to normalize like this, then this is the value of the not one. No,
this is not one.
This is not one value. Sorry. Sorry. どうしようかな. If you want to if we want to compare only the GFP one.
Only GFP one. Okay.
Only GFP. So then this is GFP. Sorry.
GFP. Okay.
GFP.
Okay.
The higher GFP came the higher PGK one maybe because if the expression of the GFP or the production of the GFP, free GFP, the processing of the free GFP is depend on the processing of the GFP is the same.
It's the same.
The ratio is the same as the three independent trial. It must be so. So, but the flexibility came the flexibility of the loading. So then the higher GFP means a higher PGK1 signal because
the higher amount of loading.
Yes.
High.
Then lower GFP means a lower amount of the loading. So then it is need to normalize as a PGK1. So then came the one. This is one. Okay.
Then we have to look after the PGK1. Whether the PGK indicates a normalized loading or intense loading.
Okay.
Now I think I understand.
Okay.
So if the amount of loading of this BY is higher, then amount of GFP will be higher because the free GFP indicates knock-on degradation.
Yes.
So more loading, more GFP. Less loading, less GFP.
Yes.
There is a variation in 1, 2, or 3 sets.
Yes.
So then we have to look after the PGK value. Whether the PGK is also indicates a higher loading or lower loading.
Yes.
If the PGK value indicates so, then we have to normalize this data.
All of the band is the lower signal. Lower or higher. Okay.
まだまだです。
So then the total volume of the GFP signal can show the same of the PGQ1 or the loading control. Because the expression level is the same.
Here is a variation in expression level.
Yes.
It has a very huge amount of degradation. It has very poor degradation. So there is a variation. Now we have to look up the PGK. But the PGK is same for this one and this one.
So I don't know why, but the PGK one.
This GFP and this GFP is seemingly different. This is BY, this is also BY. And So there is a variation. There is a upper GFP, lower GFP. This is upper amount of GFP, highest value of GFP, lowest value of GFP. So variation occurs. Now we have to look after whether the PGK value is also variant. But we found that the PGK level is okay. Then if happens so, then how we will normalize this one? The process of normalization will be what?
What means
how to calculate the normalized data?
Normalized data. For normalized to the physical one.
To the physical with respect to physical one.
We usually normalize physical one as the GFP not physical one. So then the frames physical, but this came the that one. これを A and B the A 分のA plus B 分 A, but this can be divided with the physical one value because the all of the factor contain the
physical one.
Yeah, physical one. One divided physical one.
So A is also
can be multiplied as a physical one.
Denominator and numerator.
Yeah, so eliminate the physical one. So it is. I think no idea to the.
This become the same.
Yes.
This formula ultimately, after cutting upper and lower, it become the same formula.
Same formula.
Yes. Yes, okay. You are correct. So this is not a useful formula. PGK1 A full length PGK1 B A divided by A plus B. Ultimately, the PGK is eliminated.
Yes.
It is in the denominator. It is also in the numerator.
So I have no idea to the.
So ultimately PGK1 including or not including, the result is same.
It's the same.
Same. So we have to figure it out. So it's not necessary to include PGK.
Yes, it's
ultimately
not necessary.
PGK is omitting from here. Hi, hi. Thank you very much for your time and patience for teaching me.
No problem.
And I am not a good student. I bothered you a lot.
No.
Thank you for tolerating me.
Sorry for my